All right, so this video is about factoring and solving, as well as doing a rough sketch of the graph. So it's kind of combining a lot of the things that we've learned so far in algebra, as far as we've graphed sometimes and we've solved sometimes, and we've done it for quadratics or parabolas, and we've done it for lines and linear equations. But now we're starting to branch into this. Well, what if it's to the third power? What if it's squared? Or what if it's a higher than squared? So something to the third power, the fourth power, the fifth power. So it sort of involves end behavior. It also uses all the factoring skills that we've talked about before. And now we're going to kind of combine it all together into one. So first thing I need to think about when I factor is this idea that I need to make sure that I break down into its component parts. So when I look at factoring, I always want to see if I can make the problem easier than it is. And it looks like I have x cubed minus 16x, and I could take an x out of both of them, right? So I'd have x squared minus 16 equals 0. Okay. And then I can break down x squared minus 16 because I recognize, okay, that x squared is a perfect square, 16 is a perfect square, and it's the difference, so I can actually use the difference of squares here. I take the square root of x squared, which is x and x, square root of 16, which is 4 and 4. And then it's going to be x plus 4, x minus 4. Again, you do the same thing if you did the x factor chart, and b would be 0. But that's kind of the shortcut here. If you recognize that both of those are perfect squares, and it's subtraction, you can do it this way. Okay, and then from here we can set each part equal to 0. And if we solve, it would be x equals 0. We would subtract 4, so x would be negative 4, add 4, and then x would be positive 4. So these are my three answers. If I were to solve this, and again I get three answers because it's x cubed, so I would need three of them. Okay, so I have my roots of my problem. So let's go ahead and graph those out here. So I have 0, and then 1, 2, 3, 4. I have 4, and negative 1, 2, 3, 4. I have negative 4. All right. From here, now I want to determine what is this graph shape going to look like. And we can actually determine all of that based off of x cubed. Just by looking right here, we can determine a lot of information about this function. Okay. So first thing I notice is that, of course, there's an invisible 1 in front, and that's an invisible positive 1, so the graph is positive. All right, the next thing I notice is that the exponent is an odd number, and so the highest exponent tells me it's odd. And so that means that the ends will either go from the bottom up like this, something like this, or it's going to start from the top and go down. Because the ends go in opposite directions. See what I did there? It sounds a lot like opposite. Opposite directions. Ha, ha, get it? Get it? All right, anyway. So they're odd, so they're going to go in different directions. But if it's positive, that means it's going to go from low to high. Meaning it's going to start down here and then go up like this. That's what's going to do something like that. Okay, the last thing I'm going to determine is how many turns does this graph take? Because you know how with polynomials, like it goes up and down, it can go up and down so many times. The way you determine how many times is you look at the highest exponent, 3. And the number of turns it will take is 1 less than 3. So my graph's going to take 2 turns. All right, so with all that information, we can look at the graph and say, well, I know it's going to start down here in the third quadrant. And it's going to end up here in the first quadrant because it's going to go low to high. But I have to do the turns. So if I do this, if I go up, there's a turn 1, then go back up 2, my graph would do something like that, right? So it took 2 turns, it went up, down, then back up again. And that would be a good kind of guesstimation on what my graph would look like. So, most importantly though, factoring and solving is the bread and butter. You got to do that first. And then using the end behavior and all those different tools, you can piece together what the final graph would look like. Again, if you have a graphing calculator or if you have some type of online graphing calculator, you can obviously figure out what it is. But if you're just doing a rough sketch, this would be good enough.